Am I audible?
Yes, sir.
ठीक है, start करते हैं. In last class, we have studied the different overall mechanical energy balance or Bernoulli equation using the macro fluid mechanics approach. Okay, so today we will solve one simple problem. Actually, there was a meeting in the department, that's why I couldn't come at time. So this is very small class. Today we will solve a simple problem related to the Bernoulli theorem. So water with density the density of water is 998 meter kg per meter cube is flowing with a steady state flow rate throughout a uniform diameter of pipe. Okay, so I am making the diagram. You can understand the problem through the diagram. Okay, so there is a pipe here, and in this pipe the water is flowing with a steady state, means that velocities and other properties are not changing with time. Now this pipeline is connected to a pump. So this is the pump, and this pump forces the fluid at upper direction to the point 2. So this is point 1, this is point 2. The fluid is flowing from point 1 to point 2. Okay. Now this is the pump. So in this pump, basically this pump provide, this is the pump. This pump provide the work or the energy to the system. So this is pump supplies the energy to the system, that is 155.4 joules per kg. Okay, so this is the energy which is provided by this pump to the fluid. Okay, so this is the energy which is provided by the pump to the fluid. Okay, now the difference in height of the point 1 and point 2, the difference between the height of point 1 and point 2 is 3.05 meter. The pressure at point 1 P1, that is equal to 68.9 kilonewton per meter square. The velocity, the average velocity of fluid is here V1. Okay. Now at point 2, the pressure is P2, that is equal to 137.8 kilonewton per meter square. The average velocity is at this point is V2. The Reynolds number value is given. The Reynolds number in the pipe is above 4,000 in the system. The Reynolds number throughout the pipeline is in the turbulent region. Okay, so NRE is greater than 4,000. That means it is well in the turbulent region. Okay, so what is the meaning of the turbulent region? That means value of alpha should be 1. So value of alpha is 0.5 when you have the laminar region, and when you have the turbulent region, value of alpha is 1. That you have to remember. Okay. The height is given, Z1 minus Z2 equal to 3.05 meter. Suppose this is your baseline, so you can assume Z1 equal to 0. So Z2 equal to 3.05 meter. Okay. So the next point which is given, that the pipeline, the diameter of pipe is constant. Okay, so the diameter of pipe is also constant. Okay, that is equal to D. So what will happen if the diameter of pipe is constant throughout the system? That means the velocity at point 1 and point 2 will be equal. So V1 equal to V2. Okay, so velocities will be equal. Why the velocities will be equal? Because velocity equal to Q by velocity equal to volumetric flow rate divided by area. Area is pi d square by 4. So D is constant, D is equal throughout the system, Q is constant, others are also constant. So your velocity will be constant throughout the system. Velocity will not change. Okay, so your velocity will not change throughout the system. So now you can use the Bernoulli equation at this point. So Bernoulli equation is so here we will writing V1 equal to V2. One by 2 alpha in bracket V2 square minus V1 square bracket close plus G Z2 minus Z1 plus P2 minus P1 divided by rho plus summation of F plus Ws should be equal to 0. This is the Bernoulli equation. Okay. Now here you have to calculate the friction losses in the system. What is the sigma F? That you have to calculate in this problem. Okay. So V1 equal to V2. This is equation number 1. So from equation number 1, V1 equal to V2, so this term will be 0. The kinetic energy, difference in the kinetic energy will be 0. So G Z2 minus Z1 equal to Z2 minus Z1, that is 3.05. The distance, the difference in the elevation of the 2 points are 3.05. So here you can write G multiplied by 3.05 plus P2 minus P1. So what is the value of P2? 137.8 minus 68.9. 137.8 minus 68.9 divided by rho. So rho is the density. Density value is given 998 kg per meter square. Okay, and what is the unit of pressure? That is kilonewton. Okay, so kilonewton, you have to convert kilonewton to the newton. Okay, so multiply by 1000 plus sigma f plus ws. So what is the value of ws? That is given work done by the pump 155.4. So ws is 155.4. Okay, now G is 9.8, gravity constant, that is 9.8, 9.806. Now if you solve this equation, that should be equal to 0. Okay, so G is 9.8, so it will become 29.9 plus this will become 138.0 minus 69.0 plus sigma f plus 155.4 equal to 0. Now when you solve this expression, you will get value of sigma f. The overall losses in the system, that is equal to 56.5. The unit will be joules per kg. This is the unit. If you check the unit of all quantities, that is joules per kg, because ws is also given in the joules per kg. Okay, so this is the friction loss in the system. Okay, if you compare the friction loss with the power given by the pump, so the power is given by the pump is 155.4, so you divide 56.56, you can divide 56.5 divided by 155.4. It will give you the amount of energy, which is the relative energy which is consumed due to the friction and due to the friction losses. Okay, so this is one type of problem which you can solve. You can calculate how much friction losses is there in the system by using the Bernoulli equation. Okay, now we will solve the second problem. So in this problem, there is a reservoir tank which is connected to a pump. So here you have a pump. Now this pump elevates the fluid from the this reservoir to the other reservoir which is present at the elevated level. So this reservoir is filled with the fluid. So basically this reservoir is totally filled with the fluid and you are taking the flow, you are taking the fluid from the middle point of the reservoir. Okay, so this is point 1. Here the point where, and this is the point 2 where the fluid removes from the reservoir. This is the point 2. Okay, now here you have the point 3 inside the pipe. After the pump you have the point 4. Okay, now the pipeline, this pipe, the size of this pipe is 3.068 inch. Pipe size of this pipe is, the both pipe has the different size, 2.067 inch. The overall friction losses are given. So the overall friction loss in the system F is 10.0 feet per pound force. 10.0 feet per pound force. And this is the unit in the FPS system. Okay. Now the flow rate is given in terms of volumetric flow rate. Okay, so the volumetric flow rate Q is volumetric flow rate of fluid, because this is a single line. So volumetric flow rate will be constant, but the cross-sectional area are different. So you have the different flow rate at the point 3 and point 4. Okay, so volumetric flow rate is constant. So volumetric flow rate is 69.1 gallon. So it is given in the FPS unit, 69.1 gallon per minute. This is the volumetric flow rate, and density of the fluid rho is, density of the fluid is 114.8 pound per feet cube, lb per feet cube. So this is, the units are all given in the English units, okay, or empirical units. Now the elevation, the difference in elevation of point 1 and point 2, it is given. The difference between the elevation of point 1 and point 2 is 50 feet. This is the difference between the elevation of point 1 and point 2. Okay. Now the pump, the efficiency of pump is given. Basically, what is the purpose of pump? Pump will convert the electrical energy to the mechanical energy. So some of the energy, during whenever you convert the energy from one form to the other form, based on the second law of thermodynamics, some of the energy will be loose as a entropy, and due to the entropy, that is the basic principle of the that is the second law of the thermodynamics. And whenever you convert the energy from the mechanical to the electrical to the mechanical, or the thermal to the mechanical, some of the energy will lose in the reserve from the reservoir. Okay, so you cannot convert the 100% energy from the electrical to mechanical. So the efficiency of pump is given, that is 65%. Now, what is the questions? First, you have to calculate the watt pressure must be developed by the pump. The second question is, what is the horsepower of pump? What is the size of the pump in other language? You know? So these two are the basic questions. So this is called a design problem. Okay, you have the simulated data. You have to pump the 69.1 gallon per minute of fluid, which has the density 114.8 lb from one point to the other point. The pipelines are given. Pipelines are selected generally based on the velocity that I have explained to you before. है ना? Here friction losses are also given. है ना? So here you need not to calculate the friction loss. Friction losses, the summation of the friction losses are also given. The elevation is given. You have to elevate the fluid from point 1 to point 2. The difference is 50 foot. Now you have to calculate which size of pump is required. You have to use the 1/4 horsepower pump or half horsepower pump or 1 horsepower pump or 2 horsepower pump, that you have to decide. Okay. So this is the design problem which you have to solve. So first you have to convert the flow rate from gallon per minute to the foot per feet cube per foot cube per second. Then you can calculate the velocity. So flow rate, this is given in terms of 69.1 gallon per minute. So 69.1 gallon per minute multiply by 1 minute equal to 60 seconds multiply by 1 foot cube equal to 7.481 gallon. Okay, you can take this conversion from the data book. Okay, so 1 foot cube equal to 7.481 gallon. Okay, so you can solve this and you will get the foot cube per second. Okay, so you will get 0.1539 feet cube per second of flow rate. Now you have to calculate the cross-sectional area of the pipe. So basically here, at the point 1, basically the 2 points are given where you have to calculate. Basically you have to calculate what is the power requirement. So this is the initial point, this is the end point. Because overall losses are given, you need not to solve the problem for the intermediate point. Intermediate points are required whenever you have to calculate whenever you have to compute the losses. If the losses are given, just calculate the energy difference between the initial point and final point. You will get the answer. Okay. So whenever the losses are given, just calculate the energy difference between initial point and final point. So initial point is point 1, final point is point 2. Okay. So what is the difference between the energy? What is the energy difference? That is, at this point, the velocity, because this is a reservoir tank. Okay, so the fluid is moving downward direction, but because the size of the reservoir, here we can assume that the size of the reservoir is significantly large. And because it is flowing the fluid from the reservoir, then we can assume that the size of the reservoir is significantly large. Then the velocity at this point, at point 1, is 0. Okay, relatively 0, relatively negligible. Okay, because Size of the reservoir is very high, so very large. So the volumetric flow rate will be same, 69.1 gallon per minute. So the velocity will become very negligible when you divide the cross-sectional area. So V1 equal to 0. So here we can say V1 equal to 0. Okay. Now the point 2, at point 2, the diameter of the pipe is 2.067 inch. So you can calculate the cross-sectional area, pi d square by 4. So the cross-sectional area is at point 2, the area of the cross-sectional area of the pipe is, you can calculate this pi d square by 4, 0.05134 feet square. Okay, so this is the cross-sectional area of the initial pipe, and at point 2 the area, at point 2 the cross diameter is 0.267. Okay, so this is for point 3. Okay, so at point 2 area of the 2.067 inch pipe is pi d square by 4. It will come 0.0233 feet square. Okay, now you know the cross-sectional area, then you can calculate, you know the volumetric flow rate Q. This is the flow rate Q. We can calculate the velocity. So V2 equal to Q divided by A2, and A2 equal to 0. This is A2, 0.0233. So Q equal to 0.1539 divided by 0.0233. You will get the velocity, that is equal to 6.61 feet per second. This is the velocity of the fluid at point 2. Okay, at point 1 the velocity is 0. So you can balance, now you can write the energy balance in this case. So what we have to calculate? We have to calculate the work done by the pump. Okay, so the work done by the pump can be calculated as Ws equal to V1 square by 2 Gc. So Gc is a constant which is used whenever you have the, when Gc is a constant which is used whenever you have the FPS unit. Okay, so for FPS units value of Gc is 32, that you have to remember. Okay, whenever you have the FPS unit you have to use the Gc constant minus P2 square by 2 Gc plus Z1 G divided by Gc minus Z2 G by Gc plus this is the kinetic energy, this is the potential energy, then you have the pressure energy, P1 divided by rho minus P2 divided by rho minus summation of friction losses. Okay, so that is equal to the power required in the pump. Okay, just substitute the value. V1 is 0, so if here you will get 0. Just substitute the value of V2 and solve the problem. You will get the value of, this is like 0.678. Now Z1 equal to Z1 minus Z2. So 1 point is 0, 1 point is 50. So Z1 is 0. So you will get plus 0 minus Z2 is 50. So minus 50. G value is 32. GC value is 32. Okay. So that will equal to 1. So 50 by 0. Now P1 minus P2. So P1 value is basically 0. Okay, at this point the pressure is atmospheric pressure. Okay, so this value is 0. So you can use this P1 minus P2, that should be equal to 0. Okay, so because this point is open at the atmosphere, second point is also open at the atmosphere. Okay, so at both point, because 50 foot is not a very large elevation, so the atmospheric pressure will be equal at both points. So you will say that at point P1 and P2 the pressures are equal, that is equal to the atmospheric pressure. Okay, so you can say P1 minus P2 equal to 0. So this is plus 0 minus 0. Okay, by P1 equal to P2 equal to 1 atm atmospheric pressure. Okay, minus summation of forces, it is given in the question, in the problem. Sigma. So summation of forces are given, that is equal to the friction loss. The overall friction loss is given in the problem, that is equal to 10 feet per pound force, LB force. 10 feet per pound force, and in the FPS unit. So here you can use this minus 10. Okay, so when you solve this, it will come minus 60.678. Okay, so this is the value of WS. So why it is coming in the minus sign, with the minus sign? Because you are giving the power. Okay, so power is given by the pump, so that's why it is the with minus sign. And what is the units of the WS? WS unit is fit LBF pound force fit pound force divided by pound. Okay, this is the unit of the WS. Now the efficiency of pump is given. So efficiency of pump is 0.65. So you can calculate the power requirement WP, that is equal to minus WS divided by efficiency of pump. Okay, so minus WS is 60.678 divided by efficiency of per pump is 65%, so 0.65. When you divide this, this is the actual requirement, this is the theoretical requirement. Theoretical requirement divided by efficiency, you will get the actual requirement. Okay, so it will come 93.3 foot pound force divided by pound with LBF divided by LBM. Okay, now you can convert in either, you have to convert it in the horsepower. Okay, so for converting the horsepower, you have to require the you have to convert this power requirement per pound to the energy consumption per pound to the energy per consumption per second. Okay, then only you can calculate the power. Okay, so energy consumption per unit mass hai na, this is the energy consumption per unit mass. You have to convert energy consumption rate per unit second, per unit time, then only you can convert, you calculate the horsepower. So how to convert the per unit mass to per unit second? By using the mass flow rate. So it is given, the flow rate is given volumetric flow rate is Q. So we had converted the Q in the initially Q equal to 0.1535 0.1539 feet cube per second. So this is the volumetric flow rate. 0.1539 feet cube per second. Density of the fluid is given rho. So value of rho is given 114.8 pound per feet cube. LBM divided by feet cube. So when you multiply the volumetric flow rate to the density, it will convert in the mass flow rate. Okay. So the mass flow rate equal to that is represented by m dot. This is the mass flow rate. That is equal to Q multiplied by rho. So Q is 0.1539 multiplied by rho 114.8. You will get mass flow rate 17.65 lbm per second. So this is the mass flow rate. Now the energy consumption is given in the lb foot per foot ft lbf by lpm. So basically a foot pound force divided by pound. So it can be multiplied when you multiply this with the mass flow rate. When you multiply wp with the m, you will get the, it will convert in the power, that is the foot per pound force divided by second. Okay. So basically the pump power that is equal to wp multiplied by m. Okay. So wp is given in 0. The wp is given 93.3 93.3. The unit is foot pound force divided by pound weight. Multiply by mass flow rate, that is 17.65. The unit is lbm pound divided by second. This is the unit of the mass flow rate. Now the answer is required in the horsepower. So for horsepower, 1 horsepower equal to HP, horsepower is represented by the HP, that is equal to 550 foot pound force per second. Okay. So it will converted in the horsepower. Okay. So now when you solve this problem, it will come, it will come around 3.00 HP. Okay. So the power requirement in pump is 3.00 HP. that is equal to 3.00 HP. Okay. Now the second question is, there are two questions in this problem. So you have solved the second question basically. What is the horsepower of the pump? That is the 3 horsepower. Okay. Now the first question, what is the pressure must be the pump develop? That means the what is the pressure difference between 0.3 and 0.4? That you have to calculate. Okay. So you have to calculate what is the pressure difference between the 0.3 and 0.4. So pressure developed by the pump should be equal to pressure difference between point 0.3 and 0.4. Okay, so you have to basically use the Bernoulli equation between the 0.3 and 0.4. So the elevation is same at both points. You have the same elevation. So elevation value will be 0. Z1 minus Z3 minus Z4 equal to 0. Second thing is velocity, the kinetic energy, that will be different, and Ws, you know, the friction force, the loss due to the friction force, that is 0 because only the pump is present between the flow. Okay, there is no joint, no pipeline is present in between these 2 points. Okay, so only the pump is present, so we can assume that there is a no friction loss. So the only difference is the velocity between these 2 points, the kinetic energy between these 2 points. Okay, so you can write from the Bernoulli equation, you can write P4 minus P3 divided by rho, that should be equal to V3 square by 2GC minus V4 square by 2GC. Here we assume the turbulent flow. That's why we are not using the alpha. Okay. If the flow is in the laminar region, then we have to use the value of alpha. Okay, minus Ws. So Ws we had calculated before, minus sigma f. So sigma f equal to 0. That is equal to 0 in this case. Okay. So now you have to calculate V3 and V4 first. Okay. So how to calculate V3 and V4? Based on the volumetric flow rate. So value of Q is given. So V3 equal to, here we had also calculated the cross sectional area. At 0.3, cross sectional area is 0.05134. At 0.2 and 0.4, the cross sectional area is 0.0233. Okay, and volume flow rate is Q is volumetric flow rate is 0.1539. Okay, so V3 equal to Q divided by A3. So value of Q is 0.1539 divided by A3. So A3 you have to calculate based on the cross sectional area. So it is, we have calculated before, that is 0.05134. Now calculate the value of V3 from this point. So V3 will come around 3.00 foot per second. Okay, similarly you can calculate the value of V4. So V4 equal to Q divided by A4. So Q value is 0.1539 divided by 0.0233. So that will come around 6.61 feet per second. Check this value because I think this value, there is some mistake here in calculation. Okay, I already had the calculation, so I could not check in between the class. Just check this value, this is correct or not. Okay, the process will be same. Okay, now you can use these two values. Just substitute the values here. WS you had calculated before. Here you can use, you have to use the theoretical value of the power requirement. You cannot use the actual value because actual value is something else. In the Bernoulli equation, you can only use the theoretical requirement. Okay, so actual requirement will depend upon the efficiency of pump. So the theoretical requirement is 60.678 pound force divided by pound weight. Okay, so just substitute the values, and rho is, you know, the value of rho, density of the fluid, that is also given 114.8 lbm divided by the pound per foot cube. Okay, 114.8. Just substitute these values in the equation, you will get the value of P4 minus P3. So when you substitute the value, P4 minus P3 will come as 40.8 lb force, lbf, divided by foot square. And what is the other name of the lbf by foot square? क्या बोलते हैं प्रेशर की यूनिट को? डेल्टा P equal to 40.8. What is the lbf by divided by foot square? psi.
प्रेशर का सर यूनिट होता है.
हाँ, प्रेशर की यूनिट होती है psi, है ना? So 40.8 psi. So this is the English unit of the pressure. Okay, you can convert it in the Pascal, kilopascal. So if you convert it in the kilopascal, you have to divide by 14.6. It will become around 3.31 kilopascal. Okay, if you use the MKS unit. So this is how you have to solve the problem. So in next class we will solve more problem related to the energy balance. तो समझ में आया आपको कैसे सॉल्व करना है?
हाँ सर, इजी था, मतलब एक बार एक देखना पड़ेगा.
बेसिकली कैलकुलेशंस है, आपको फार्मूले याद होने चाहिए और बाकी कैलकुलेशंस है. इसमें जो मेन चीज होती है वो होती है डायमेंशंस को आपको ध्यान रखना है ना? डायमेंशंस चेंज होती हैं तो यू हैव टू टेक केयर अबाउट द डायमेंशंस. कहीं पर कोई चीज सेंटीमीटर में दी है या ग्राम में दी है, दूसरी जगह पर कहीं पर किलो न्यूटन दिया है, कहीं पर न्यूटन दिया है, तो किलो जूल में दी है कहीं पर यूनिट. तो यू हैव टू टेक केयर ऑफ डायमेंशंस. एंड ऑलवेज रिमेंबर, जहां एनर्जी बैलेंस हो रहा है तो एनर्जी बैलेंस पर यूनिट मास होता है. ओके, बर्नौली इक्वेशन जो डिफाइन है वो पर यूनिट मास है, एनर्जी पर यूनिट मास. बट जहां पर आपको पावर आउटपुट बताना है फॉर द सिस्टम, दैट शुड बी गिवन इन द एनर्जी पर यूनिट टाइम. Okay, power of the pump, power of the system, power, electric power requirement, that should be given in the energy per unit time. So multiply with the mass flow rate, it will convert it in the energy per unit time. Otherwise, the Bernoulli equation is given in the energy per unit mass, joules per kg, or lbf divided by lbm. Okay, so this is the unit of the this is the unit of the Bernoulli equation. Okay, and when you use the power, convert it in the energy per second. Okay, we will solve more problem in next classes.
सर जैसे ये क्वेश्चन था, तो इसमें अगर शुरुआत से ऐसा यूनिट करके सॉल्व करना ज्यादा इजी रहता है या फिर जो क्वेश्चन में यूनिट्स दिया हुआ है उसको लेकर सॉल्व करना?
जनरली प्रॉब्लम्स ऐसा यूनिट पे ही होती हैं, लेकिन बिकॉज अगर कहीं पर जरूरत पड़ गई एफपीएस की, तो यू शुड नो हाउ टू यूज द एफपीएस. दैट्स व्हाई 1 or 2 प्रॉब्लम इज गिवन इन द एफपीएस आल्सो. बिकॉज एफपीएस में क्या होता है, आपको जीसी वाली टर्म आ जाती है ना, v क्यूब बाय जीसी. सो इंस्टेड ऑफ जी यू हैव द जीसी. ओके, जीसी इज आल्सो 32 है ना, एंड जी इज आल्सो 32. सो जी बाय जी सी आपको मल्टीप्लाई करना होता है थ्रू आउट द इक्वेशन। ओके, सो ये जो टर्म होती है इस टर्म को आपको याद रखना होता है, अदरवाइज द आंसर विल बी रॉन्ग। दैट्स व्हाई वो क्या करते हैं कि आपको एफपीएस यूनिट की अलग से प्रॉब्लम, एक या दो प्रॉब्लम एफपीएस यूनिट की आपको हर जगह मिलेगी, है ना। तो एक आध प्रॉब्लम एफपीएस में सॉल्व करके देख लो, सो यू कैन रिमेम्बर। एग्जाम में आप उसको ऐसा यूनिट में कन्वर्ट करके सॉल्व कर लेना, कोई प्रॉब्लम नहीं है, ठीक है। यू कैन यूज यूनिट
ओके
बेस्ड
सर।
ऑन योर कंफर्ट, है ना, जो आपको सही लगे वो यूनिट आप यूज कर सकते हो। और किसी को कुछ पूछना है? ठीक है, क्लास अभी खत्म करते हैं, नेक्स्ट वीक में फिर और क्वेश्चंस करेंगे।
ओके सर।
और प्रोजेक्ट बनाना शुरू कर दो, फिर नेक्स्ट मंथ आपकी प्रेजेंटेशन होगी अराउंड 15 अप्रैल के बाद से, है ना। एक वीक हम प्रेजेंटेशन के लिए रखेंगे।